Chapter 11, Section 5, Evaluation of Classification Performance. This section covers how to evaluate the prediction performance of a classification model. For simplicity, let's focus on a case of a binary classification. We can apply the same evaluation method to classification problems with more than two classes. In a binary classification problem, there are two classes, and each observation can be classified into either of them. So, the actual class for an observation can be negative or positive. The classification model outputs a predicted class for each observation. It can also be negative or positive. So, both actual negative cases and actual positive cases can be predicted as either negative or positive. So, combining the actual classes and predicted classes, there are four patterns that can be depicted as these four cells. If an observation's actual class is positive and the classification model predicted as positive, we can say the classification model makes a correct prediction. Such cases are called true positives. If the actual class is negative and the model predicts it as negative, the model makes a correct prediction. Such cases are called true negatives. If the actual class is negative, but the model predicts it as positive, the model makes a wrong prediction. Such cases are called false positives. If the actual class is positive, but the model predicts it as negative, the model makes a wrong prediction. Such cases are called false negatives. A classification model's prediction result and its correctness can be organized by such a matrix. This matrix is called a confusion matrix. Each observation analyzed in a classification can be grouped into one of the four cells. Among the four cells, true positives and true negatives are correctly predicted observations. And false positives and false negatives are wrongly predicted observations. So, the proportion of the sum of true positives and true negatives in the total observations represent the proportion of correct prediction. It is called accuracy, the most popular metric of a classification model's performance. It can be computed by this formula. Accuracy quantifies how identical the actual classes and the predicted classes are. Let's look at an example. This confusion matrix expresses the result of a binary classification problem. The number of total observations are 100. 50 of them are true positives, and 45 are true negatives. And 2 of them are false positives, and 3 are false negatives. In this case, the accuracy score can be computed by this equation, and it is 0.95. So, 95% of the observations are correctly classified. The model achieved a good classification, isn't it? But how about this case? According to the formula, the accuracy is 0.95. Can we regard the classification performance as excellent? At least in some cases, we should say this classification performed poorly. It is because, although there are 5 positive cases, the number of true positive is 0. That is, the model cannot identify any of the positive cases. This can be a serious problem in cases where positive cases are emergency and severely detrimental, such as bankruptcy and serious health problems. So, high accuracy does not necessarily mean that the classification model is useful. This problem often occurs when the distribution of positives and negatives is imbalanced. In this case, most of the observations are negatives. Since 95% of the observations are negatives, this classification can easily achieve 0.95 of accuracy by just classifying all observations as negatives. Therefore, we should keep in mind that accuracy does not provide us with sufficient information when the class distribution is imbalanced. To address these limitations of accuracy, we can use other metrics that evaluate the performance of a classification model from different perspectives. In the next video, we will see those other metrics. We need to use various metrics to evaluate a classification model, and we should focus on appropriate metrics depending on the nature of the classification problem. Thank you for watching. Please thumbs up and subscribe to my channel.